Hi everyone, I am Teja Dronadula, candidate master on Codeforces. I've been candidate master since 1 month or 2 months. I don't know how long it has been. How do I escape? How to come out of this candidate master thing? Like, if I do good in one division plus division one plus division two, can I get out of this candidate master, or am I stuck here forever? It's like you're lonely. I'm coming in middle now. Recently, I want to grow hair again, right? So I'm coming in middle. Like the video, guys. Where are you guys? It's a private live stream. Where are you people? We have 50 seconds. So let's do pre-contest ritual. So we do well in the contest. I have happy dent, not happy dent, orbit. You have to keep on equal size to not alter your facial symmetry. Otherwise, if you're chewing on one side, your face will become asymmetric over time. And also, you should not be breathing with your mouth while you're sleeping. Purchase my Looks Maxing course. It's just 300 rupees per month. Find the link, it's hidden somewhere. And NBA Posture Engineer Mario has a binary string S of length and it's a Mario game. In one move, you can choose any position I such that it's between two ones, that is, set SI to either 1 or 0. So if there are two ones, you can set that to either 1 or 0. Mario can perform this operation any number of times as he wants. What is the minimum and maximum number of ones that can be in the resulting string? To be able to change something to 1 or 0, are there any obvious upper bounds or lower bounds? Like here, if there are two zeros, you cannot do anything. Two zeros is like a break. What is this reminder to me? Is this like a death threat? Make sure to screen record and upload, or else, what will happen to me, or else? It should not be too difficult. What can you say if there are two zeros that breaks, right? If there are two zeros that breaks it, what the fuck happened to this? What the fuck have happened to my VS Code? What would be the minimum value? What would be the maximum value? I should be doing well in this contest. I have been candidate master for too long, way too long. So if there are two zeros, these things breaks. Do you get what I mean? These things breaks things because this zero can never become one. This zero can never become one because there can never be in between. So now we have to just worry about these things where there are no two zeros at all. Okay, if there are no two zeros at all, you can make them all of them as ones, and then you can make them like this. And then I think another best thing is this, just this. After that, you cannot do much. So it's about these one things. It's about this one lens. And maximum is you can make all of them as ones, Maximum is simple. Just break from this two zeros things. You get only one classes, you can make all of them as ones. If you look at maximum, one component, this is the one with two zeros, so the maximum is 5. This is the one component without two zeros, so maximum is 9. This is the one component without two zeros, so the maximum is 1, 2, 3, 4, 5, 6, 7. What about minimum? I think it's equivalent to go to here because you can come back. Operations are reversible, right? Making all of them as ones is equivalent. So let's make all of them as ones. Now think about the problem. If you now think about the problem, you can obviously see the minimum is seal. Is it seal? Here it is. It's seal plus one sometimes. But yeah, it is solvable though. If it's an odd number, it's still. If it's an even number, you have to remove this one and then it's plus half. It's half plus one. Half minus one. Sorry, half plus one. Length of half plus one. So you just have to get the ones that doesn't break with respect to two zeros. Do you get what I mean? Find a one, keep going until there are not two consecutive zeros. Let's say I will just take the lens, okay? I will start from here, ignoring zeros. So now we started at a 1. We keep going until there are no two consecutive zeros, okay? While j plus 1 less than n. Let's just push a 0 to the n for our safety purpose. So now while j plus 1 less than n plus, while j less than n, and not of s of j plus 1 equals to 0 and s of j plus 1 equals to 0. While this doesn't happen, while there are no two zeros, you can keep going. So the j you land on is either the last j or it is uh, the j that has two zeros. So what would be the length now that you're worried about? This would be the length now, not plus one, just j minus I. This would be the length that you are worrying about. So now in answer equals to 0. What is the maximum value? Let's say answer min max. I think I can just find answers here itself. Min plus equals to j minus 1 by 2 minus 1. So I'll just do it clearly, okay? Len equals to j minus I. Len reminder 2, we saw that it is len plus 1 by 2. Else, we saw that it is len by 2 plus 1. Minimum number of ones. Max plus equals to len. I equals to j or j minus 1, anything works. Let's just make it j minus 1 as we do that in general. So is that the problem? Are we done? pausing. Maybe that's just the problem. So all you have to do is identify that zero zero is the thing that breaks, and then solution follows immediately because see zero zero is the one that breaks. So without zero zero, I'm trying to collect the number of ones carefully. Wait a minute, have I fucked this up? No, I haven't fucked this up. I was thinking about only one zero at the end, but that doesn't happen. We got too many solves compared to me. Well, you look like yourself, but you're somebody else. It's only ain't on the surface. Let N, M, and L. Why does this look scary? Be positive integers. We have made the unfortunate decision to work at night at Freddy Firework Pizzeria, where there are M animatrix number from 1 to M waiting to jump scare you. Okay, it should be scary if it is jump scaring and Freddy Fazbear's Pizzeria. The night consists of L seconds, number from 1 to L. The death of the mth animatrix has danger level D. Initially, all danger levels are 0. Every second, the danger level of exactly one animatrix will increase by 1, and throughout the night, you are able to observe all the values of DJ at the current time. For example, if m equals to 2, after 5 seconds, 1, 1, 1, 1, 1. You're not defenseless, however, at each of the n fixed times, AI, A2, so on, the night consists of L seconds. You can shine your flashlight on exactly one animatronic JI of your choice. In these fixed times, you can do that, it seems. This occurs immediately after the 8th second and sets its danger level back to 0. Note that this choice is made independently for each flashlight. Use AI. Let the overall danger be the maximum danger across all animatrix. You will lose if the overall danger at the end of the night is greater than X. Find the minimum value of X such that regardless of actions of the animatrix, you can guarantee the overall danger is less than or equals to X. So you have some points. Why does this look difficult? See, the problems may appear difficult, but what is problem solving? Problem solving is about simplifying things. You have to look how can you simplify this shit. You have to look how can you simplify this. You have some points at which you can make something zero, okay? You have some points at which you can make something zero. So what is the state? State is like initially everything is zero, plus one, plus one, plus one, plus one happening. It can happen anywhere. And you can make something zero here, and then you can make something zero there, and then you can make something zero here. If you never touch something, think about that. If you never touch some animatronic, its value will keep on, maybe in one of the scenario, only its value kept increasing, let's say. Then the answer will be L. Do you see what I mean? So this n should be greater than or equals to n. If n less than L, answer is L. What am I missing here? Sorry, if n less than m, we have m animatrix, right? Oh, it has more logic in it. Damn. Because you won't fix priorly. Like you can take decisions based on the current state. Right. So the logic is that when there are two animatrix, at the tenth thing you can see that one of them will have greater than or equals to 5. So you remove that one. So the other thing will be having less than or equals to 5. That's nice. So when you're trying to remove something, is removing maximum always the best? Think of that. What happens if m equals to 1 and you have different times? We will make 0 here and then answer will be 32 minus 25. So let's just say what we can say. If there are only two things and wait a minute, it's always okay, not just two things. Let's say n equals to 1 and a1 equals to l. If you think of this, answer here is what the fuck is that? Answer is here is l by 2 because the best that can do is trying to place everything in just the two things because you can remove one but you cannot remove the other one. Placing in only one thing is bad because you will just remove that thing. Placing in three things seems useless because you can anyway touch the one, right? So placing in two things seems the best and then the other guy will remove maximum. So this is one thing. So is it always beneficial to make it m equals to 2? Think of that one. M can be anything, but let's just think of it. Maybe is it always beneficial to make m equals to 2 for the animatrix danger levels? Why? They're increasing one by one, and once something becomes 0, maximum will be removed again. At each step, removing maximum is best. Because position doesn't matter. You can rearrange them as you like. If position doesn't matter, removing maximum seems the best, right? It's obvious. But is this one true? The guy will keep on removing maximum. So if you're having other things in multiple things, that seems useless, right? So what is the optimal way? Can you figure out the optimal way that you'll keep on keeping on one thing? You keep on keeping on two things. Okay? Because maximum will be removed at any time. So the optimal thing is to keep on keeping on two things. And once that has been removed, the optimal thing is to keep on keeping on here. And once they become equal, again optimal thing is to keep on keeping on like that. So we just have two values that will try to half as we keep going. And once a removal comes, what do we do? We remove that. But we have m into l does not exceed 2 into 10. This doesn't matter if we can solve it in O of L, right? Let's try to solve it in O of L. They gave m to confuse us maybe. Because maintaining two things seems the optimal for the other guy because one will be removed and trying to keep them equal when one has been removed, try to fill that one. Whatever is minimum, you just fill that. Whatever is maximum will get removed. If m equals to 1, answer equals to, if m equals to 1, you can just fill that. See, sum of L plus 1 also doesn't exceed, okay? Wait a minute. Yeah, sum of L plus 1 doesn't exceed, sum of test cases also doesn't exceed. And what is N? N is the number of points. Everything seems fine. We'll just collect those things. We just collected where all 1 will come. If M is to 1, what is answer? There is only one thing. You can only fill that. Answer will be L minus A of N minus 1. That's written here. L says maintain two things. X comma Y. Okay? Oh, sorry. Now we will try to simulate L things. Okay? L. If this happens, we keep doing that. If x greater than y, let's say swap of x comma y. X will always be minimum. If that is 0, you have to remove that. Else what you have to do? You have to make y equals to 0. So these are the two cases. Removing maximum, increasing minimum. Simple. X will always be minimum. Now what's the answer finally? So we have to make some statements and then do this problem. Maybe they're not dark, my dreams small, let me know. All the stars are closer. All the stars are. What is happening? Here I have to do L minus A of N minus 1. Oops. Let's just get max. So those things are correct. What are some other things that are going wrong? This is going wrong somehow. One. Okay, this happens regardless. If A of I this, then this happens. But this thing happens regardless. You can do this again and again. Did I fuck up something? Wait, is using more things better? Because it's M into L, right? Maybe using more things is better. Is there some other greedy algorithm? I have to be more concrete with my assumptions. When can using more things may be better? If that guy can remove only one of them, think of like you keep in three things, and then only one of them will be removed. Now we have two things. Now we can start from here and here, making keeping two things as better. Is it always better to do number of removals left? Maybe if you have if you have jet removals coming incoming, split into jet plus one things. Maybe this is the optimal. It feels so, right? Let's say this is true. For z equals to 1, it's true. For z equals to, let's try to think about that. For z equals to maybe k, if it is to can prove it for z equals to k plus 1 somehow. Because if you're making them almost equal, when one thing comes, they'll remove one of that. Now, to start from here, the optimal thing is if you're trying to fill all of them, having all of them already filled seems the optimal thing, right? So what we will do is we'll try to cyclically fill not just two things, but Z plus M plus 1 things, okay? Not M plus 1 things, L plus 1 things. We'll optimally try to fill the L plus 1 things and then they keep on removing them. I think that can be a solution. If n equals to L, I'll just output that earlier. Because all of them should be distinct. When something comes, you can remove that. Maybe this will be covered in here, but let me just remove that. So now you have n things. You have L plus 1 things here. But you only have M monsters. So you'll split them into minimum of. Initially n things remaining, right? Your optimal goal is to split them into this. Okay? And then maximum will be removed. Let's just have the sum and let's just have number of things that have been filled. That we have been trying to fill. With this, we will know the structure because you have to fill uniformly, right? So now we won't fill one thing, we will fill. Now we're trying to fill the whole, this whole thing, but I'm just trying to use two arrays, two numbers called sum and z, number of things that we have tried to fill, okay? So now sum will be equal split into z things, okay? What happens? Sum plus plus will happen, and then what happens? If we have 5, what will happen is we'll try to remove this thing. See, remaining is minus minus, and Oh, when M is small, this shit is not working. It's just me, right? What's happening to me? No, I'm overcomplicating it. When M is small is what all I'm worrying about. When M is small, what's the answer? Well, you look like somebody else. You just try to make M things equal. That's what you do, I think. So I will just split that into that. If N is small, I can see the solution, but you'll try to fill M things equally, okay? If you have more than M things, okay? If remaining things are more than M, until then you will try to fill them equally, right? But then when something has been removed, you'll just try to fill the last one. And then if something else has been removed, I will try to fill these two things. I'll get some water from it. I'll skip to C in the worst case, and then come back. I have an idea on B, right? That's my bonded. She has some idea on B. I'll skip to C and come back. I should not be wasting too much time. It's been 41 minutes already. Let N, H be positive integers. Swampy, the alligator, needs water for his bathtub. A task with getting it to him. Above his house, there is an N cross, H cross, and grade of dirt and water tiles with N columns numbered from 1 comma N. Each column I, the bottom AI tiles are dirt and the rest or water. To get water to Swampy, you can place a drain on any tile that isn't a dirt. Placing a drain takes away the water tiles that can access the drain by moving only down, left, or right on the grid without crossing any dirt tiles. Example, placing the drain on the X in the grid below. That makes sense, right? Placing the drain takes away all water tiles that can access the drain by moving only down, left, or right. That seems reasonable. For example, placing the X in the grid will take away 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 months, 10 things. What's the maximum amount of water you can get to Swampy after placing at most two drains? You have any small, but one thing is clear. If you're choosing one column, you will choose the bottommost. Okay? That's clear. Let's try to look at two dots. There will, if there are two x's, somewhere here and somewhere here, okay, there will be cells drainable by both, by only one, and by only other. Right? This thing you can see. What are the things that are drainable by both? Let's say without loss of generality, one is here and the other one is here somewhere. Then things that can be drained by both will have, in between these two things, if you see the maximum, that height will be less than or equals to both of them. You can say that they are above the maximum height is what you can say, because if they're not above the maximum height, okay, maximum height in between the drains, they're either on this side or either on this side, right? And if they are on this side, they cannot reach this one. If they are on this side, they cannot reach that one. So with respect to this maximum height, the common things will get split into. The common things will get, you can count the common things with respect to the maximum height here. I held the better part, I could find you, I could say to. Everything that's taller than the middle height of this and reachable to one of that can reach this also, because if you see this thing, this is the maximum height. Here you have one more x, let's say. Let's say if it is coming from somewhere here, it can come here too. If it is coming from somewhere here, it can come here too. But if it is in the less than that, it will only go to either one of these things, because if it is in the less than height, see, it cannot cross this one to come here. So with the maximum height in between, you can stop what things will come here and what things will not come here. And for something to come to this hole, that should be higher than maximum height in between. You can do this in n square. I have to count number of tiles, maximum number of tiles. Can you drain one and then drain the remaining one? Let's say you're trying to drain one thing, and you can remove, based on that you can compute all the things, all the new things. Now you have to think about the problem in O of n. If you're trying to think about the problem in O of n, now nothing can go to that. So if you're coming from here to this side, if you're somehow coming from here to this side, all of them are zero. If you get something that is non-zero that you can drain, then it can only drain things from this side. Or it can drain from this side also, but it has some boundary here. It can drain some things from this side, and it can drain some things from this side. But the things that can be drained from this side, you can compute that for all of the things. And the things that can be drained from this side, you can compute that also. Starting from here, you can compute that for all of the things. And you can do that on this side and this side also after you fix this shit. So is it just brute force then? Fix one thing, compute in O of n. After that, fix the other thing and then compute in O of n. Is it just brute force then? Fuck, people are solving it somehow much, much better than me. So fix one thing, try to drain everything that's possible. Okay, if we're going this side, let's try to find the maximum dirt. Whatever is above that can be taken away. And then you have this one. And then you try to find the same value again. Try to come from this side and try to remove whatever the things that can be removed from this side, whatever the things that can be removed from this side. Then for each thing you can know whatever the things that can be removed from this drain. So I want something that returns me two arrays. Things that can be drained from this side, things that can be drained from this side, given an array. So we'll take some set of water, and it will give us things that can be drained from this side and things that can be drained from this side. Both it will give us. The amount of quantity that can be drained from this side, the amount of quantity that can be drained from this side. But before that, we can brute force the values. So let's fix one drain and brute force both sides. So let's do left swiping of this. Let's do left sweeping of this. Cut equals to a of I, let's say, and then we are trying to do the left sweeping. Cut equals to maximum of comma a of j. Okay, b of j equals to minimum of b of j comma cur, because if that's the maximum thing, you can only remove till there, right? Let's do this on this side too. So now you have water levels with respect to this thing. Fuck, why am I not able to do anything? I didn't get the solution. I didn't get a solution. I didn't get a proper solution, and then I'm coding. CP. Let's look at one thing, this column. Okay, how much water that can be drained by this hole? This much can be drained. For this one, maybe a bit more. This much can be drained. Right? So when you fix two things, it's like minimum of those two things will become the answer. So in O of n cube, it's easy. So let's fix one thing. See, my other solution is still would still work, but it became complex with the heights not being fixed. With that, finding for all of these things might not be that easy. Let me read some other question. Yeah, n can be possible is given a tree with n vertices numbered from 1 to n. Duckquill is traversing this tree and is trying to reach one of its leaves initially. He starts from a non-leaf vertex v and in one turn, he may either choose to stay still or move to a vertex v along an edge to any of his neighbors u. However, Snorlax is trying to stop Cyndaquil from doing this by sleeping on an edge. When he picks an edge, Cynical is blocked from traversing it until Snorlax moves again. Fortunately, only one edge may be disallowed at a time, so that the most recently chosen edge is blocked. Of course, Snorlax is slow and needs some time before he can pick a new edge. Has a cooldown timer initially at 0. He may only choose a new edge when the cooldown is 0 or lower. When he moves to an edge, the timer is set to K. After each, the cooldown decreases by acting as previously described with first, sleeping on any edge. Assume both of them play optimally can Syndac will always reach a leaf after a finite number of moves. This seems a nice problem to me. We have a parameter k, we have a parameter. What is v? It's his initial vertex, and then we had to think about can he reach or not. Right, let's try to think of it a little bit. Yes, I'm not getting it. Let's try to. I mean, I got a little bit, but I'm not getting it. Let me try to think of this problem. As a cooldown timer, he can block something. Okay, if he has multiple things that are leaves, done, and let's just call them C, comma S. C wins. When can S win? Before you go to towards one of the leaf direction, he can block that thing. And then before you go to the some other thing from here, he can block that also. K is the timer, right? So it's like you're trying to move, something is blocked, and then let's say he's blocking this thing. Cannot let you go to that edge. See, sometimes Sinakul can just wait. He can wait until you move towards somewhere, then he can start acting. See, what about k equals to 1? What about k equals to n? How it depends on k equals to n? Let's look at from V all the leaf distances. Uh, uh, we're trying to simplify things, right? When things looks complex, we have to try to simplify them. So let's look at two different leaves. Are problems becoming too difficult these days? I thought this in same E problem on division 2, but then it was easier. Let me read even 2. What's wrong in reading? What's the other version? It's the kth whole. So what does this exactly mean? For this prefix, so because with respect to an, you can know the one max of that array. The first missing thing you can know. No, by removing one thing, Yeah, he does not have to do it immediately, that we know. One day, maybe someday, I'm a bad orchestra. I got not necessary conditions coming from back. One day, maybe someday, in a bad orchestra. Are you lonely? Our fingers dancing as they may. You seem so lonely. Are you lonely? Can you make this to be the second zero? Can you make this to be the second zero by making that would be the condition? Okay. This zero can will persist because it's coming from everything, right? So it can either be here or it can be either here. But this says an extra thing that you have to be able to make. Fuck it, fuck it. I don't know what's happening here. So if you're coming from back, let's say using jet things, you know what this jet is. Can you make, I mean, there are jet things in the start. You don't worry about their conditions. Can you make lost remaining? It's too sad. Can you make lost remaining things satisfy some condition using jet things? So for what happens to the beginning one, like you should be able to make using you should be able to make this structure using jet things by being able to remove X things. Should not have given the contest, I guess. By being able to remove the this side things, see, you can use jet things, okay? You know the structure that with respect to this structure, you can remove one more thing. And can you come here or not? Underneath the why am I recording this shit? I'm thinking of Dina. If there are two things, let's just see the just let's just think about this graph, okay, of length this much. So wherever you are, you will try to go towards the other leaf, and then he will apply that. He will block the end. Then you have to come back. So where you are here, this was blocked then. Now this maximum distance that is there, which is number of edges minus one, if that is greater than or equals to, that is less than k, you can go. Else in the last second the timer will be reset, then he will block that. Else you can't. So for this simple line, we can try to see this thing. What about thinking about three things? Let's say there are three things. What can you say then? I wanted to solve problems, but I don't know what's happening. I should not be streaming this. What about when there are three things? You can try to go towards one thing, and then if that is blocked, you try to go to the minimum closest leaf. Then if that gets blocked, what is even? Is this possible? With this being empty, all of them being filled, is this possible? Is the question. Have these many things. So the answer might be n less than or equals to n plus 1 is first one necessary condition. Okay. If that happens, then what about a2? Now you have this as your whole, right? N plus 1. So if the second whole equals to this, that means something is missing here. That means bn less than an, bn greater than an. Let's just see these two cases. If bn greater than an, then in this case, an minus 1 must be greater than n plus. An minus 1 must be greater than an. If bn greater than an, something else has been gone. And all of them has to be ones. An minus 1 minus 2 wholes should be greater than or equals to n. But Bn is less than an, that will be gone. That may or may not be gone again. If Bn is less than an, I can't do this shit, guys. I'm sorry, I guess. I'm ending the stream. I won't do this contest. I'm dropping. I'm dropping in between. I'm dropping in between.